In this chapter, we're going to apply the fundamental theorem of arithmetic to the least common multiple and the greatest common divisor, least common multiple. It is the smallest number that can be divided, that can be distributed equally between the numbers in question. Then, the technical criterion of this concept establishes that, with the number in question expressed in prime factors and in power, the prime numbers are multiplied with the largest of the exponents that appear. The LCM is applied in the addition and subtraction of fractions, also in the solution of a question with denominators, rational equations. Let's see an example with 9, 18, and 27. Among these, there are many common multiples, like 4374. This is a common multiple of the triplet, as is the 8748, but these are not the minimum. There is no greatest common multiple. We are going to determine the least common multiple. First, we are going to decompose each one. Once decomposed, we express the prime factors in power. Here, it is verified that a number is equal to the product of the prime factors that compose it. After expressing the prime factors in power, we select the prime factors that appeared in the decomposition of all of the numbers. These were 2 and 3. Second, the selected factors will be used with the highest of their resulting exponents. The LCM. It is the product of the configured prime factors with the largest of the exponents. Raising them, then we have the 27 by 2 is 54. This is the smallest number that can be divided by the triplet. Greatest common divisor. We continue with the application of the TFA. The greatest common divisor of 2 or more natural numbers is the greatest number that can divide the numbers in question. What is the greatest common divisor used for? We use it in the application of the distributive property. We are going to determine the greatest common divisor between 9, 18, and 27. First, we prime each particular number and then express them in power, applying in this way the fundamental theorem of arithmetic. First, from the prime factors that appeared 2 and 3, we select those that repeat in all numbers. In this case, only 3 appears in all the compositions. The classifying prime is used with the smallest of its exponents. We see that the 3 is the only one that appears in all the compositions and that its smallest exponent is 2. When raising it, we have 9. This is the largest number that can be a divisor of 27, 9, and 18. It is possible that the greatest common divisor between a group of numbers in question doesn't exist. The greatest common divisor is also used in factoring cases, especially those of common factor. We are going to apply the least common multiple to the addition and subtraction of fractions. In this expression, using as an example the denominators worked on in the previous part, 9, 18, and 27, first we determine the least common multiple. With 54, which will be the denominator of the result, we divide the common denominator by the denominator of each term. We multiply it with the respective numerators and add the products. The sum of this multiplication will be the numerator of the result. Least common multiple between variables. If we have, for example, variables that are similar with different exponents, Then the least common multiple between these variables will be the one with the largest of the exponents, in this case x to 5. Application of the greatest common divisor in cases of common factor. If we have, for example, the following expression, then the greatest common divisor between variables is x at 2, the one with the lowest exponent, and between the number is 9. The product of the number with the variable gives us the common factor. This is a divisor between each term that will go into the grouping. The quotient of each division enters the grouping, respecting its law of signs. Please support us on Patreon, subscribe, share, and hit the like button.